Welcome back. Now we start on problems on section 5.3, volumes by cylindrical shells. Problem 1. Match the following integrals with the solid whose volume it represents. So you have 4 volumes and 4 integrals. We want to match one with the other. So let me go over one volume at a time. The first volume of the solid obtained by rotating the region described by y is between 0 and 2, x is between 0 and 1 over 1 plus y squared. You want to rotate this about the x-axis. So, x equals 0 is the y-axis. X equals 1 by y squared is this curve. Y equals 0 is the x-axis. Y equals 2 is this horizontal line. So you want the region bounded by these 4 things. Curve, line, line, line. So that's the region. And you want to rotate this region about the x-axis. Okay. So when I rotate this region, I get a picture like this. Okay. So notice it's well connected. So when I rotate, I have a solid and you have cylinders, right? So where do you have cylinders? Y goes from 0 to 2. The width of each cylindrical shell is delta y. Y goes from 0 to 2. So integral 0 to 2. 2 pi radius. Well, for each cylinder, radius is this distance. So that's the y coordinate of your point. So y coordinate is the distance. So that's the radius. What's the height of your cylinder? Height is the x coordinate. X coordinate is 1 over 1 plus y squared because x, you're bound by this curve on the right, you see. So that's the height and that's the radius. So the expression is, you get the 2 pi out, integral 0 to 2, y times this fraction. So y times 1, y divided by 1 plus y squared. So for the first volume, B is the answer. All right. The volume of the solid obtained by, so that's the second one. Volume of the solid obtained by rotating the region described by x is between 0 and 3, y is between 0 and x to the power 4. Okay. So x is between 0 and 3. x0 is y-axis. x3 is this vertical line. y0 is the x-axis. And y equals x to the power 4 is this curve. So your region is between the x-axis, y-axis, this vertical line, and this curve. So that's your region. And you want to rotate it about the y-axis. So when I rotate this region about the y-axis, the solid looks something like this, right? Okay. So when we rotate it, so what's happening? When x is 3 and when x is 0, for each x from 0 to 3, you have a cylinder of width delta x. The radius is the x coordinate and height is the y coordinate. Y coordinate is x to the power 4 because that's the curve. So radius is x coordinate, height is y coordinate, which is x to the 4, and x goes from 0 to 3. So limits 0 to 3, 2 pi x, that's the radius, and that's the height dx. When you simplify x to the power 5, 2 pi comes out, integral 0 to 3. So integral 0 to 3, 2 pi comes out, x to the power 5. So that's the second one. Third one, volume obtained between sine and cosine. So let's look at the picture. So solid obtained by rotating the region bounded by x is between 0 and pi by 4, y is between sine and cosine x. You want to take this region and rotate it about the line x equals pi. Okay. Now, x equals 0 is the y-axis. X equals pi over 4 happens somewhere here. Y equals sine x is the blue curve. Y equals cosine x is the green curve. So, you see, when x is pi by 4, sine x and cosine x, they agree. It's root 2 over 2. So, you're looking at the region x equals 0. So, that's y-axis between the two curves and x equals pi by 4. So, that's the region. You want to rotate this region about the line x equals pi. X equals pi is somewhere away, you see. When x is pi, sine is 0, cosine is -1. So yeah, you're in the right location. So you want to take this region, rotate it about this line. All right. So you get a solid which looks like this. So you had that region, you rotated it about the line x equals pi. So you have a wide region but with a big hole in between. Now, thickness is delta x. X goes from 0 to pi over 4. Height of each cylinder is upper curve minus lower curve. All right. So, radius is x. My integral goes from 0 to pi over 4. Radius, that's a good one. Center is here, not here. So, radius is my distance from here to here. Well, this coordinate is x coordinate. X coordinate is distance from the y-axis. So, radius from here, that is the entire distance minus x coordinate. Entire distance is pi minus x. Entire distance is pi minus x. That's the radius. Height is upper curve minus lower curve. Right? That's the height of each cylinder. So volume of the solid is integral 0 to pi over 4, 2 pi minus x, cosine x minus sine x. The only thing I would complain about this drawing is that it seems the height should be correctly drawn. There you go. Likewise, this one. There you go. So now that's better. Okay. All right. Now that's better. So height is higher y coordinate minus lower y coordinate. Radius, mind you, I'm not measuring from here. I have to measure from here. So you keep going until you hit your curve, right? Your point for which you are looking at the cylindrical shell. So if that's the x coordinate, radius is all of pi minus x coordinate. So that's the expression for the volume. So this is, here we go, D. Okay, third one is a D. The last one, well, A, B, D is taken, so that's a C, but let's figure out. The fourth one is volume of the solid obtained by rotating the region bounded by xy squared, x equals 1, y equals 0, above the line y equals 3. All right. X equals y squared is a parabola which looks like this, right? Sideways parabola. X equals 1 is a vertical line. Y equals 0, that's the x-axis. So, region between the parabola, this line and this line is this region. You want to take that region and rotate it about the line y equals 3. Y equals 3 is high above. So you want to take this region, rotate it about this line. So the solid looks like this. So that's y equals 3 for you. Here is the region we began with, and you're rotating it about so it goes some more distance high. So notice radius has to be measured from here, here, or here to here. All right. What does that say? Well, for any point here, radius is, well, all of 3 minus the y coordinate. You see? Because y coordinate is the distance from the x-axis to go up. So all of 3 minus the y coordinate is this radius. Whereas the height is this distance, height of the cylinder. What's that distance? Well, that distance is 1 minus the x coordinate. But x itself is y power 2 on this curve. So 1 minus x, that is 1 minus y squared, is the height. So for each y from 0 to 1, radius of the cylinder is 3 minus y, all of 3 minus y, while the height of each cylinder is 1 minus x. But x itself is y squared. Notice the thickness is up-down thickness, so that's delta y. In other words, you're taking integration with respect to y. So make sure all your working variables are y. So volume is 0 to 1, 2 pi radius, height dy. So that is here, C. All right, so every one of those is correct. Next problem, I'll continue in the next video.